Hello everyone, welcome to Math Cafe. This is Silagna, your maths mentor. Today we are beginning with differentiation. So if you haven't seen the previous videos of continuity and differentiability, I will leave a link in the description box. So today's video will cover product and quotient and chain rule. So let's get started. You have already studied about differentiation in class 11. Differentiation is a method of finding the derivative of a function, or in other words, you can say it is a process where we find the instantaneous rate of change of function based on one of its variable. That means if the function y is equal to fx, x is the variable of function and we have to find the derivative of y with respect to x, or the rate of change of y with respect to x. X is known as the independent variable and y is the dependent variable, and it is written as dy by dx or f dash x. So here I have taken a random curve y is equal to fx and a random point A on it. So if this line L is a tangent to the curve at point A, then the slope of this line L is the derivative of curve y is equal to fx at the fixed point A. So here are the derivative of some standard function. Derivative of x to the power n is equal to nx to the power n minus 1. Derivative of e to the power x is equal to e to the power x. Derivative of a to the power x is equal to a to the power x ln a. Derivative of ln x is equal to 1 by x. Derivative of log x is equal to 1 by x log a e. Derivative of sin x is equal to cos x. Cos x is equal to minus sin x. Derivative of tan x is equal to sec square x. Derivative of cot x is equal to minus cos x square x. Derivative of sec x is equal to sec x into tan x. And derivative of cosec x is equal to minus cosec x into cot x. So now let's move to some important rules of derivative. First is sum or difference rule. That means if the function is sum or difference of two functions, then the derivative of the function is the sum or difference of the derivative of the individual functions. Like if fx is equal to ux plus minus vx, then f dash x is equal to u dash x plus minus v dash x. So if we'll take an example, that is fx is equal to x square minus e to the power x. Then f dash x is equal to derivative of x square minus derivative of e to the power x. That is 2x minus e to the power x. And if our function is x cube plus ln x, then f dash x is equal to 3x square plus 1 by x. So this is the sum or difference rule. Next is product rule. So if the function is the product of a scalar and a function, then its derivative is the product of the scalar and derivative of that function. But if the function is the product of two functions ux and vx, like fx is equal to ux into vx, then f dash x is equal to derivative of first function into second function plus first function into derivative of second function. For example, if fx is equal to x sin x, then f dash x is equal to derivative of first function into second function plus first function into derivative of second function. This is equal to sin x plus x cos x. So this is the product rule. Let's take another example. If the function is product of three functions fx, then how we will find out its derivative? F dash x is equal to, we have to split this three function into two parts. So suppose we will take xex as one function and sin x as one function. Then what we will do? Derivative of x e to the power x into sin x plus x e to the power x into derivative of sin x. But this is also a product of two functions. So again we have to split according to our product rule. So this is d by dx of x into e to the power x plus x into d by dx of e to the power x. This whole multiplied by sin x plus x e to the power x cos x. So this is equal to, this is 1 e to the power x. So e to the power x plus x e to the power x into sin x plus x e to the power x cos x. So this is equal to e to the power x sin x plus x e to the power x sin x plus x e to the power x cos x. So in case of 3 or 4 function, we have to split it like this. So there is a rule, if the function is the product of n number of function, then its derivative is equal to derivative of first function into all other function plus derivative of second function into rest of function, then derivative of third function into rest of function, and so on. So you can directly apply this formula if your function is the product of more than 2 derivatives. So now let's move to quotient rule. Quotient, that means the function is in the p by q form. If the function fx is in the form of two functions ux divided by vx, then the derivative of the function is, that is fx is equal to ux by vx, then f dash x is equal to u dash x into vx. That means derivative of first function into second function minus first function into derivative of second function whole divided by square of the second function. For example, if fx is equal to x square by e to the power x, then f dash x is equal to d by dx of x square into e to the power x minus x into d by dx of e to the power x whole divided by e to the power x square. So this is equal to 2x e to the power x minus x, here x square e to the power x divided by e to the power 2x. And after simplifying again, what we'll get? We can cancel 1 e to the power x here. So our function will be x into 2 minus x divided by e to the power x. Now is the most important chain rule which you are going to apply in all other form of differentiation. So what is chain rule? If the function y is equal to fx is equal to zu And if u is equal to hx, then the chain rule of differentiation is defined as dy by dx is equal to dy by du into du by dx. That means if our main function is the function of a function, so here fx is equal to g of hx. So in this case, we are applying chain rule like dy by du into du by dx. Let's take an example. Suppose fx is equal to sine x square. So it is not the direct function of x. Here sine is the function of x square, where x square is the function of x. So what we'll do? So here we'll apply chain rule. How? We'll take fx is equal to sine u, where ux is equal to x square. So dy by dx is equal to dy by du into du by dx. So this is d by du of sine u into d by dx of x square. So this is cos u into 2x. So what is u? U is our x square. So this is 2x cos x square. So let's solve some other question so that you will be clear about this chain rule. Here y is equal to sine of ln x to the power 5. So it is a function of a function of a function. Find dy by dx. So what we'll do? So let's take x to the power 5 is equal to t, and ln x to the power 5 is equal to u, and sine ln x to the power 5 is equal to y. So what we'll get? After differentiating, dt by dx is equal to 5x to the power 4. And here du by dt, because x to the power is t, du by dt means d by d of x to the power 5 into ln x to the power 5. So this equals to 1 by x to the power 5. And here what we'll get? dy by du equals to d of d ln x to the power 5, because u is ln x to the power 5, sine ln x to the power 5. So this is cos ln x to the power 5. So what is dy by dx? Dy by dx here is equal to dy by du into du by dt into dt by dx. So what we'll get? Our answer will be dy by du is equal to cos ln x to the power 5 into 1 by x to the power 5 into 5x to the power 4. So after simplifying this, what we'll get? Here only x will remain. So answer will be 5 cos ln x to the power 5 divided by x. So in this way, we'll apply chain rule. So in the coming videos, we'll do more questions questions on chain rule, or in the further classes when we'll discuss about various form of differentiation, in many questions we'll apply this chain rule. So from those questions you will be very clear of this chain rule. So that's all for today. So please like the video and do subscribe my channel and press the bell icon so that you will get all the notifications. So work hard and keep studying.